Okay, this is a brutal puzzle. It takes a lot of advanced logic, and I had X's almost filling the screen before I placed my first star. So let's see what we can do here on a second go through. You can quickly put a couple X's in these eye shapes because they would ruin the rest of the shape there. In the top two rows, you need 4 stars, and a lot of the top two rows come from this shape here. Outside of this shape, the only squares in the top two rows are these 7 here. So at most you could get 1, 2, and then the other 2 stars would have to come from this shape. So you know that none of these will be stars because we need 2 from this shape in the top 2 rows. We also know this square can't be a star because we need 2 stars from something other than this shape, if that makes sense. This could be a star, or you could have 2 from this shape, 2 from these 7 squares. If this were a star, then none of these could be, and then you'd only get 1. So, okay, looking at this eye shape here, we don't know yet if you have 2 stars up here and none down here, or vice versa, or a split. So we sort of play with that. If there were 2 stars down here, it would really eliminate this whole area of this shape, and you'd only have these 3 boxes for 2 stars. So we know that there are not 2 stars down here. So at least 1 star is among these 3, so I can cross this guy out. If I did it the other way, it would eliminate this whole row, which means this shape stars are both on the top row, and that doesn't seem possible. Let's play with that. That would leave this to be a star and this to be a star. So if these were all X's, you have 3 boxes left for 2 stars, so it has to be here and here. And this one would eliminate all 3 of these and all 3 of these, and this one would eliminate this, so you'd only end up with 1 star in this shape. So you can't have both of these as stars. So we know they're split. There's 1 here, and there's 1 here, and if there's one of these 3, then we can X this guy out as well. If this box here were a star, it would eliminate all of these. You'd be left with a star here and a star here. If this is a star, this shape's stars would be here, blocking out this box, and here, blocking out both of those. We know one of these 3 is a star, therefore this cannot be a star. Okay, we know this square cannot be a star because it would eliminate all of these, and you'd be just left with 2 here. Okay, if this square were a star, it would eliminate all 4 of these squares in this eye shape, forcing the stars to be here and here, but that eliminates a huge swath of this shape here, and you'd be left with only 3 squares for 2 stars. So working that back, this cannot be a star because of the chain reaction. Okay, since we know in the top 3 rows, we're going to have 6 stars, 2 from this shape, 2 from this shape, because they're completely within the top 3 rows. We already know there's 1 up here and 1 down here, so the 5th star will come here, which means the 6th star has to be one of these 3. So this cannot be a star. Moving left to right on these 2 rows here, you'll have 1 star in one of these 2 squares, 1 in one of these 3, 1 in one of these 4, and 1 in one of these 3. So if one of these 2 has to be a star, we can block out that guy. If one of these 2 is a star and only one is up here and the other one is down here, then we can block out this guy. Looking at this third and fourth row, one of these two is a star, one of these two is a star, one of these four, and one of these three. So now that we're down to two here, we can erase those two. So it's one of these two, one of these two. If this square here were a star, it would force the eye shape to have both of its stars here on top of each other. But that would eliminate all but one of this TF shape's squares. Okay, so if this is a star, then these four here get eliminated, and these two are all that's left. This star would eliminate these two, and this star would eliminate these three. So this cannot be a star. It's sort of like that trial and error, guess and check, but I feel like if you can take a couple mental steps and sort of logically eliminate it, it's not the lazier try something and see if it works. I'm trying to figure out if they're both on top, both on bottom, or split, kind of like we did over here. We know they can't both be on top because we know one of these two is a star. So they're either split or they're both on the bottom. So we know at least one is on the bottom. So we can eliminate this square here since one of these three will be a star. But could both of them be on the bottom? I don't think it's necessarily a problem for this shape because you could still have two of these four. If both of these were on the bottom, you could still get away with this shape here. This shape would have all four. I'm sorry, this shape, if they were both on the bottom, these two squares would be eliminated. So both of this row's stars would be in the bottom row, which means none of these could be here for this shape, but there's only this one mini L left, and you can't put two stars there. So again, kind of following a few logical steps. They can't both be down here. They can't both be up here. So it's split. So I can also eliminate this guy. So there'll be one of these three and one of these three. So for this row here, we know one of these two is a star, and we know one of these three is a star. So anything other than those two and those three in this row can be eliminated. Okay, if we look at these two rows here, we can go across and figure out kind of where the stars lie. So one of these three will be a star. One of these three will be a star. One of these two will be a star, which we know already. And now we know that one of these two will be a star. I guess we already knew that. I just didn't ever X that out. Follow my logic here. If this here were a star, it would force this shape, all these would get X'd out, to have both stars on the end here. Okay, which means none of these would be, which means this shape would have to be here and here, but we already forced two stars in this column, so then you'd have a third one. So if this is a star, these two would have to be stars, forcing these two to be stars, which can't be, so this cannot be a star. I was looking at the bottom three rows, trying to figure out, I need 6 stars, 2 here, 1 here. So the last star in the bottom 3 rows is either one of these three, or this square here, or one of these two. So could I say that one of these two has to be a star? If they weren't stars, then you'd have this square and this square would have to be stars. But if these were both stars, it would eliminate both of these blocks here. So these two cannot both be stars, so one of these two has to be a star. again, if one of these two is a star, you got two more in this shape, that's three, and two more in this shape, that's five, and we know one of these three is a star, that's six, then I can eliminate this, this, and this as not being stars in these bottom three rows. Okay, coming across these two rows here now, we've got one star here, one here, one here, and one here. So if one of these two is a star and there's only one on this bottom area, then we can eliminate this guy. And now we also know that one of these two is a star, so we can eliminate these. Okay, if this were a star, it would eliminate too many squares in this shape for there to be two more spaces for stars. So this cannot be a star, which means it's one of these two and one of these two, which means we can get rid of this guy. And we can finally place an actual star. This one has to be a star because it's one of these two. This one, we only had three other squares in these first two, or these last two columns, so this one had to be a star. All done.